The rate of change of an exponential graph depends on the value of a in the equation y equals a to the x. So recall for growth, that value of a is greater than 1. So all three of the equations, y equals 1.5 to the x, y equals 2 to the x, and y equals 5 to the x, are examples of growth equations. Also, if we plug in 0 for any of these x values, we'll get the y value 1. So all of these graphs go through the point 0, 1. So the graph y equals 1.5 to the x looks something like this. And y equals 2 to the x looks something like this. And y equals 5 to the x looks like this. So notice that as the a value increases, the graph becomes steeper or closer to the y-axis. But each of these graphs goes through the point 0, 1, and each also has the asymptote at y equals 0. It's just the rate of the change of the graph changes as we change the value of a. Now this also happens for decay graphs, which if you recall, decay is when the a value is between 0 and 1. So the graph 1/2 to the x is also going to go through the point 0, 1, and it'll look something like this. And the graph of y equals 1/10 to the x looks like this. So both of the graphs go through 0, 1, and they again have the asymptote at y equals 0 at the x-axis. So they approach the x-axis as x goes towards positive infinity. But if we think about these values of a, 1/10 is really 0.1, so this equation is 0.1 to the x. And 1/2 is, as a decimal, 0.5, so this is 0.5 to the x. So the graph becomes steeper or closer to the y-axis as the value of a gets closer to 0, or as the denominator of the fraction for decay increases. So as a decreases to 0, or to say that a different way, as the denominator grows, the decay graph becomes steeper. So for growth, as a increases, the graph becomes steeper. So we can see that 5 to the x is steeper than 2 to the x, or closer to the y-axis. And for decay, as a decreases to 0, or as the denominator grows, the decay graph becomes steeper. So for example, 1/10 to the x is steeper than 1/2 to the x. Let's look at an example where we compare several different graphs. The graph below contains the following functions. Match the correct function with the correct graph. So we have 6 equations and 6 graphs. Let's start by looking at the decay functions, which are 1 through 3 here. So all the functions with a less than 1, and which are functions f, e, and c, because those are the functions that are decreasing. Okay, so from the previous slide, the steeper the graph, the closer the a value is to 0. So the steepest decay graph is E, so that would go with 0.3x, or the lowest a value. So because that is closest to 0. And then the next steepest graph would be the next closest to 0 for the a values, which is C. So 0.4 to the x would go with graph C. And the least steep decay graph is the one with the value closest to 1, so that would be graph F. Now let's look at the growth graphs, which are the remaining ones, so B, D, and A. And for growth, the greater the a value, determines how steep the graph is. So if the a value is greater, this means we have a steeper graph. Or the closest to the y-axis. So y equals 3.5 to the x, one with the greatest a value, goes with graph B, which has the greatest rate of change. The next largest a value, so 2.5 to the x, goes with the next steepest, which is D, and then the least steep, or the one with the lowest rate of change, is A, so that growth graph would go with 1.4.